Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm teaching you wave mechanics for chemistry. This is lecture number 14 in the series and I will discuss about Hamiltonian operator for different elements like hydrogen, helium, lithium, etc. and some ions also. Well, Hamiltonian operator H is also known as total energy operator. Now, first of all, I would like to discuss what is the meaning of total energy. You know that total energy of any system is equal to kinetic energy plus potential energy. For us, for macroscopic particle in solid physics, we use kinetic energy is equal to half mv square plus potential energy. The symbol is U or capital V. Well, kinetic energy is equal to half mv square and U is equal to mgh, where m is mass, g is gravitational force and h is Planck's constant. So sorry, height. H is not a Planck constant. Sorry, it is height of the substance. Okay, so this is what total energy for any substance in solid physics. But we are dealing with quantum mechanical model of atom, and in case of atom there is no gravitational force or there is no height, so we can't use U for potential energy in case. Okay, so in this case Bohr explain what is potential energy for atom, and according to Bohr, potential energy of atom is equal to minus Z square upon R. So here there is a nucleus, there is an electron. If nucleus is positive, electron is negative, and there will be attraction between these two particles. So because of attraction between particles, they attract each other and therefore their energy should be taken negative. Okay, this shows attraction. Z is atomic number and E will be charge on particles and R will be distance between two particles. So this way, according to Bohr, potential energy is given as minus Z square upon R. Okay, Z is atomic number. Now, let us see Hamiltonian operator. So Hamiltonian operator symbol is H, and Schrodinger's wave equation will be H psi is equal to E psi. In Schrodinger wave equation, E stands for total energy. And if psi is an eigenfunction, then E will be eigenvalue and H is also eigenvalue. Therefore, H is equal to E is equal to total energy. Okay. So, in case of Hamiltonian operator with Schrodinger's wave equation, H is a Hamiltonian operator and that is also equals to total energy, and that is minus h square upon 8 pi square m bracket del square upon del x square plus del square upon del y square plus del square upon del z square psi or plus capital V. Okay, so capital V indicate potential energy, and therefore this part become kinetic energy. Okay, so this part become kinetic energy according to conventions. Okay, So for Hamiltonian operator, if we use Laplacian operator for this one we use Laplacian operator, then the shortest form of Hamiltonian operator H would be minus h square upon 8 pi square m bracket del square plus capital V. Okay, this is the case for Hamiltonian operator. Okay, now it is used to determine the total energy. For this is for single electron, so we can use this for single electron. We can write H is equal to minus h square upon 8 pi square m del square minus e square upon r if there is only single electron. Okay, for two electrons we can use H is equal to minus h square upon 8 pi square m. As there are two different electrons, so we have to use two Laplacian operators, one for first electron, another for second electron, plus V, potential energy. Okay, similarly for n electrons we can use H is equal to minus h square upon 8 pi square m Laplacian operator V1 square plus V2 square plus dot 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 plus Vn square plus potential energy V. Okay, so this is a general formula for all more than one electron system. Okay, similarly we can use for different elements also. We can apply this Laplacian operator for different elements. Okay, so here this is page number 40. Okay, and I will explain this for calculations for of Hamiltonian operator for hydrogen atom. Now we know what is hydrogen atom. It is the only one atom having one nucleus, one proton and one electron. Okay, the distance between nucleus and electron, say r. Okay, this is the charge of nucleus, say E plus, and here the charge of electron is E minus. Okay, so for hydrogen atom, potential energy V is equal to minus Z square upon R. As Z is equal to 1 for hydrogen, we write minus E square upon R. Okay, and therefore Hamiltonian operator, as there is only one electron, there will be only one Laplacian operator for this. So Hamiltonian operator for hydrogen, that is total energy of hydrogen, is equal to minus h square upon 8 pi square m Laplacian operator mu bar square plus potential energy V. So substitute the value of potential energy. So total energy of hydrogen is equal to minus h square upon 8 pi square m Laplacian operator del square minus E square upon R. This shows total energy operator for hydrogen atom. Okay, and we are taking negative sign over here because V is equal to minus E square upon R, because there is only attraction between proton and electron, between nucleus and electron. Therefore, negative sign is used. Okay, so this is the case for hydrogen atom. Thank you so much.